Good evening, everybody. So I'll I'll talk about FAYA POTT as we move forward. The first session that we are having is Tech Bytes. How many of you are coming here for the first time? Okay. So Tech Byte is a session where we discuss about, it's a technology roundup where we discuss about the recent tech advancements that has happened in the past month. We have this FAYA POTT happening every month. So we'll get started with this. I want all of you to engage. Okay, so that's when this session will become interesting. So the first story that we have is this, right? So the question that I have for all of you is that, what do you prefer? Do you prefer artificial intelligence LLMs giving answer faster without knowing the quality, or do you want high quality good answers to come from AI? All of you? Right. So with the current chat GPT or whatever LLMs you guys are using, Gemini or whatever you're using, do you see any problems? Hallucination. What kind of hallucination?
Like sometimes it creates information that does not exist.
Exactly. That's one problem. Okay. I would call it shallow reasoning. That's one problem that is there. What is the other problem? It'll hallucinate, it'll give strong answers confidently, right? Wrong answers confidently. Right. Exactly, that's right. That happens with humans as well. Yeah. And anything else? Yeah. So bad reasoning, that's one problem. Another problem is that it doesn't have a context. I mean to say, you ask 15 questions, after that it forgets the first question that you have asked ChatGPT. It doesn't remember, right? So it doesn't store that much of information. It's not possible, right? The third problem that we see is that it cannot index videos, text, I mean to say videos, links, all those things well, right? This is what is the current problem with the LLMs that are there. And all these problems, this jinx is broken by, okay, Gemini 2.5 Pro, right? So this is known as one of the best LLMs available until now, right? We'll just quickly look at this video. I'm not going to play the entire video. You can,
Google
I'll give
just
you.
released the best model ever created. That is not hyperbole. It is not only beating every other model on the benchmarks, I've tested it thoroughly, and it is able to one-shot some of the most impressive demos I've ever seen. Look at this first one. So this is a Rubik's Cube. Now it's a 3D Rubik's Cube. You can generate any size of Rubik's Cube that you want, and then let's scramble it. So it is actually persisting all the colors in the right spot. It is absolutely stunning. Now, some of you may be thinking, well, that's not that impressive, but I've tried this with every other model pretty much, and none of them are even able to come close to getting it working. And so you can see some of the colors are missing, the rotation doesn't look right, it's not persisting the colors during rotation, but now look.
You can watch this entire video later. I don't want to take too much time, but this is what is happening, right? So this particular model uses something called as inner monologue. So if you ask a question, it processes the information like an intelligent human being and gives you an answer after thinking, right? And that answer is 100% accurate. That's what they claim. Okay, we don't know how it is moving forward, but as of now, it looks 100% accurate. Plus, it also indexes everything, video, text, whatever, images, links, whatever you give, everything is there. It is now available for free, but for small tokens. If you want more tokens, that is, if you want more information, more data to be stored, you'll have to pay for it. But you can test it out. It's available. All right, you can go to the next one.
Now, Google just released the best.
Okay, so how many of you here use AI to generate images? Right, what is the tool that you're using? Stable Diffusion, okay. Midjourney, Canva, they all claim to be one of the best, right? So the problem that Midjourney, my team, I'm from marketing, so my team uses Midjourney extensively, right? So it has a lot of complex prompts. Am I right? Lot of complex prompts, different types of prompts. You have to copy prompts, put it here, then you'll get something that's not right. It's not conversational, it's not interactive, right? Similarly, if you look at when you try to generate an image, sometimes it is pixelated, doesn't get the right kind of image. Now, ChatGPT has integrated DAL E3, right? So now this you can generate images easily as conversations. Just say that you want a picture of your of Donald Trump is in McDonald's store, you will get it, right? So we'll quickly look at a video. I don't want to spend the entire time there, but just look at this, you'll get an understanding of this.
However, OpenAI just went out and told people on the market with the release of the ability to render our AI girlfriends into specific layers, unlike most other image generators. But every time that all your favorite memes have been ruined by GPT-4o. In today's it redeemed itself by shipping some actual fire. This tool has allowed me to throw graphic design software like Canva in the garbage, because now I can create infographics and marketing material with near perfect text rendering. It even produced an almost good comic strip for me, and it can even handle transparency layers unlike most other image generators. But everybody's talking about its ability to transform images into specific art styles. That's pretty cool, but the significant thing here is that it gives us the ability to render our AI girlfriends in ways that were previously impossible by maintaining character continuity. Like now I can upgrade her with new poses, new outfits. However, OpenAI just went out.
You can watch this entire video. I'll share the slides with you, but this is also one recent technological update that has happened, right? So you can read more about that in WSJ report. All right, so our next topic for discussion is fast food meeting faster thinking, right? So if you look at all the restaurants around the world, one restaurant that stands on the top of operational excellence. Operational excellence is you don't have to wait in long queues. You will get your food faster, and the quality of that food will also be at a certain standard. Which restaurant comes to your mind when I say this? Don't say Anand restaurant in Kadakutam that gives chicken biryani. McDonald's, absolutely. That's because, see, you read about it, operational excellence is their motto right from the start until now. Okay, so operational excellence is when you invest a lot in technology to ensure that customers don't wait and your employees are happy, right? So that's what McDonald's has done. McDonald's have integrated AI. Okay, yeah, if you don't use AI, you're outdated, right? So, yeah, integrated AI in 43,000 stores across the globe, and by 2026 they estimate it will be available for available in every store. Now what this does is that it provides real time information on when the crowd will be higher, what type of food will they purchase, so that the entire resource can be allocated there, and it also sends signals on which machine will go out of order at a particular time, right? Now how many of you have tried I think it is called as McFurry, the ice cream that they serve? How many of you have tried that? Do you love it or do you like it? You like it, right? I didn't know that it's that great until my 3-year-old son, when he goes to Lulu, he always cries for that ice cream. Okay, I got a ice cream from a better shop and gave it to him. He said, "Idalla." He wants McFurry, right? That's because it's the softest ice cream. In fact, there is an app in USA that says which McFurry machine is not working, right? It's that important. McFurry machine has a lot of issues. So they have this AI that is integrated that tells which McFurry machine is going to go out of order at this time. It predicts, so they can get the repair person in faster and they can serve better. In fact, there's a survey that says that 15 to 20% of McDonald's employees are unhappy because there are too many customers that they have to handle, right? So this is going to take care of it. I wonder when they'll do a survey like that for Technopark. Yeah. Okay, so the last topic that I have is, can your thoughts speak? Is it possible that how is it possible?
Have like controlling devices with your mind kind of a technology.
Has it happened? Have you read about it somewhere? Where is it happening? Did you see Stephen Hawking speaking? Was it using AI at that time? Sorry? Yeah, eyeball movement and cheek muscle movement, not AI. Okay. In fact, okay, so UC Berkeley, they have developed a system which is called as neuroprocesses, brain to voice neuroprocesses. So there is one lady who who was not able to speak, 18 ALS and stuffs like that. She was not able to speak for almost 18 years, and then this transmitter was inserted in the part inside the brain which is responsible for speaking, and that sent signals to AI, which converted this to words, and there's a digital avatar that speaks for that lady. We can quickly look at that video. That's a breakthrough in in medical field now. You can just move the cursor there. Yeah, leave it there. This is how it is. It's not this slow actually. I think it's a rendering that is happening. It's not this slow. It's quite fast. The best part is this is real time and it is happening. It was not happening real time in earlier time. Okay, the last tech bite session that I had is now. Did you now when you search in Google, do you now visit multiple sites to get information, or do you just read AI overview and run away from Google? Okay, so is it good? Sometimes. It's definitely not good for me. You know why? Because I am in digital marketing and we did a lot of SEO. Right. So yeah, so it's kind of taking away our traffic from SEO. However, what has happened is that the traditional SEO of using keywords, insertion, all those type of content, those things are not working anymore. Right? What is working is GEO. What is GEO? Have you heard about this? Okay, it's called as generative experience optimization, right? So SEO is now becoming GEO, right? So now context, intent, and quality matters more than anything. If the context is there, quality is there, and intent is there, that means you'd have a lot of FAQs in your content. Then Google will pick that and start showing that in AI overview, right? So these are the major tech updates. We could not put everything together, but we thought whatever is interesting, we put it together. Okay, so I've already taken 15 minutes, so let me get to the next part faster. I'm sorry, Anurag, I'm taking more time. All right, okay, so uh, first of all, let me welcome all of you for the 126th edition of FAYA Poteti. FAYA Poteti started about 12 years back. This floor, you know what is the name of this floor? Floor of Madness. Okay, so that's the name. Floor of Madness. 12 years back, a group of tech enthusiasts they came together and they said that every month Wednesday we'll have a session where we'll discuss and we'll have speakers, we'll discuss, we'll share knowledge, right? So it had very clear objective at that time. The objective was that you share knowledge and you grow using that knowledge, right? And that is the building block of FAYA Poteti, which still stands true, right? Even now, it is all about sharing knowledge, learning through knowledge, through that knowledge, and growing. Now, every time we have a lot of speakers who come and talk about AI, LLMs, and stuff like that, right? So this time, when there's a committee for FAYA Poteti every month. This time, Deepu came to us and said that we should have a different topic this time. Let's not have something related to AI or LLM. Let's have something else. And then we thought, okay, we'll have something on space because space sounds cool, right? But then we were concerned whether we'll get the right person to talk about space tech, satellite, and all, right? So that's when we came across Anurag Reghu, okay, the speaker for today's session. But before I introduce Anurag Reghu, let me ask you a question. How would you feel if I tell you that the first ride-sharing satellite in India was launched from Kerala? How will you feel? Ride-sharing satellite. Don't ask me what is ride-sharing satellite. Anurag will tell that. You feel excited? Okay. If I tell you that this ride-sharing satellite, or this satellite, I would say, was launched from a company in Technopark, how would you feel? Feel proud? You know the name of the satellite? It's called Nila. Does it ringing some bells? Nila is the name of the building nearby, right? And that's the building where Hex 20 lab is situated. So Anurag Reghu is the co-founder and director of Hex 20 lab. Now this company is revolutionizing satellite technology, right? So what this company has done is this company has put Technopark Kerala in the forefront of satellite technology, right? And I think Anurag and his team deserves all the credit for it, right? So I think there's no better person who can talk about space tech, satellite tech, and the innovations happening in the industry better than Anurag. So Anurag has 20 years of extensive experience in embedded systems, robotics, okay, so R&D and multiple different departments. And I think in today's session, he's going to enlighten us on what are the innovations that are happening in satellite technology field. How do we get equipped to utilize this advancements that are happening? And I think you all should get ready to go beyond Earth as well as beyond your expectations. So I'd want to leave the floor to Anurag. Thank you, Anurag, for coming.
Thank you. Good evening. Good evening all. Thank you very much, FAYA, for inviting me to this talk. That was a nice introduction for Hex20. So, as you said, we started in 2021, but we were dormant because of some issues here in Kerala related to space. And in 2022 end, we started our operations here in Trivandrum. So during that 1.5 years, we incorporated a company in Australia, and we like got selected into an accelerator program there in Australia, where we got a small project from Australian Space Agency and NASA to do some study on a Moon Mars mission. So that was the first project what we got. Later, 2 years later, we started here in Trivandrum. Fortunately, we got an order from UAE Space Agency to build a laboratory test bed, which is required for them to understand satellite technology. So that was the first project that we executed. So we did that in an Airbnb, rented Airbnb, and we within 2 months we completed that project, and we shipped that to UAE. And in UAE, we trained 30 engineers who were selected for UAE Space Agency. So that was the breakthrough for us. That happened 2.5 years back. Then, again, fortunately, we got projects, satellite projects from Taiwan. So I will come to that later. So currently we are having missions. And Nila is the first satellite from Hex20. It was launched on March 15th about Transporter 13, which is the Falcon 9 from SpaceX. Now it is in orbit. And we are also having ground station in Marian College where we can track this satellite. So that is where we stand as of now. Okay. And in this session, I won't be going in depth into satellite technology, but they broadly gave us the topic of discussion, like what's the industry like, how you will be beneficial, what do you need to look into, those kind of things. Let it be an interactive session, okay? So with that, I will start. So the topic, sorry. So this is the track which is given to me, right? So basically, like I will try to give some snapshot about where we, like our journey as a species, right? So we'll take some snapshots and discuss and where we are and where we can go in future. So that is, in a nutshell, what we will be, or I will be presenting to you today. And In between, like I will also throw light on what we are doing in Hex20. So we'll get an idea of like the kind of work we are into. And if some students who are interested in space technology, like who want to collaborate with us, we are okay to collaborate with you. But it's limited to few people because we are a team of 19. But we have limited bandwidth, so we are having such discussions with Bibu as well. So basically, like this is a journey, right? Like 200 years back, our species walked out of Africa. Now we are walking in moon, right? So that's the journey of our species, right? So we are, our curiosity never ends. We are exploring, and as a species, we are explorers, right? So that still continues. And if you look at in 1903, the New York Times predicted that there won't be a man flight or a flight for the 1 to 10 million years. That was an article which came in New York Times, like highlighted here. Okay. After 8 weeks, Wright brothers had their first flight. Just after 8 weeks. So the human relayed earlier, like in 14,000, I think Copernicus came out with the heliocentric theory, and we have Galileo started. These people were looking at the universe, right, on celestial bodies and how they move, their motions. They recorded a lot of things, but there was no mathematical. It's data. There's no mathematical support for that. But after Newton's thing, classical physics came into being, so everything got into picture. So these are some images, right? This the first telescope and Galileo. Do you know him? So he's a person who found first liquid engine, Goddard. So that's the second name, and this one is the first time, 1957. Okay, this is the humble beginning of ISRO, right? And we came a long way, right? And do you know this? Yeah. So this is in operation for the last 30 plus years, right? And you know this one? Yeah, James Webb. So what's the specialty? Yeah, and it is launched in 2021 and has life of 5, but can work till 20 years. Pardon? Yeah, like L2 point. Right, you're right. So specialty is, so it can see the past 13.2 billion years back, right? So that's the specialty, 13.2 billion years back. So that's the specialty of this particular place. And design is also a peculiar hexagon kind of mirrors. So I'm not going in depth in this. So this is the start, like where we came, now where we are, and where we are planning to go. So that will be the nutshell of the discussion of talk today. Okay. So I said the telescope leads to astronomy, but with launch vehicles, we were able to explore more, right? So launch vehicle actually paved way for right? So these are few launch vehicles. Like this one, can you identify this one? On the left? GSLV Mark 3. What's the payload capacity? Close to 10 ton in lower top. Okay, I'm only talking about lower. So this one is second one. Falcon. It's a Falcon Heavy. This right. It can take up to 60 tons. So this is the SLS from NASA for the Artemis mission. So this is 130 tons. Okay. And this one is the Falcon again rocket, like the transport of rockets in which Nila also traveled. It is close to 22 lakhs, full year. And this is from a company called Rocket Lab, again for small satellite mission. And this is yeah. And this one is, can you identify this? This is India's private, one of the India's private launch vehicle manufacturer called Skyroot. So their rocket is
Vikram?
called Vikram, right? Okay. And this one.
PSLV.
So basically, a launch vehicle, rockets or launch vehicles triggered space technology. And if you know, like there are 100 plus launch vehicle companies across the globe. Many more are coming. Some are operating, and some are in the development phase. And I will show you a statistics towards the end of this session regarding the space uh, companies in India. So how it is growing up. Okay. So that is it. This is like introduction to break the ice. So to getting into these topics. Now, sorry. Now coming to satellite, right? So it is classified into different categories based on the mass. Okay. So a large satellite is more than 1,000 kg. Okay. You can compare with the Rhino. Okay. And this one is nano, something like a raccoon, which is less than 10 kg. So this is how it is classified. Okay. So anything like INSAT kind of satellite, which is 3 tons and more, is in this category. Here, like something like a INS, something like that. Here, maybe the SpaceX Starlink satellites falls into this category. This is a micro satellite, INS, that is from ISRO, small satellite from ISRO. This is NILA. Again, the satellite ISRO main records. But like how it happened is in 1999, Jody and Bob Phillips, they came up with a standard called CubeSat standard. So they tried to standardize the CubeSat for academia and research purpose. So a lot of people got into this and developed CubeSats, especially in Western countries, US. So sorry, sorry. Okay, so one U is 10 centimeter by 10 centimeter into 10 centimeter. That is one U. So this can be arranged in different configurations, right? So 1U, 2U, 3U, then 3, 2, 3U will become a 6U, like that. So up to 27U we can do that. So it's a standard shape. 27U is a box of 1 meter cube. Okay. And 1U means 1.3 kg to 2 kg maximum. 1.3 to 2 kg. So if you take 27U, this will be 1.3 times that. Or worst case, 2 times. Okay. So it can go up to 50 kg. Okay. So that is why it is called, it will come under the category of microsatellite. Okay. So this is a standard which many in the like earlier academic institutions were using it for their research. But later what happened is, you know, that miniaturization is happening. So you now have an NVIDIA board, right, which can do wonders, right? So those kind of boards are coming. Power is, the consumption of power is also low. And sensors are getting optimized in shape, size, and the performance. So people started using like satellites in this particular category, like from 10 to 124 bigger task. Okay, so if you look at Starlink, so their mass is somewhere between that 500 range. Okay, and so it's doing it's for communication, right? So likewise, like you also might have heard about OneWeb. They are also in the same space. And now Amazon, their constellation is named Kuiper. So they are coming up with 27 satellites this year or maybe early next year. So a lot of people are into this, especially from a communication perspective. But there are other use cases as well. Okay. Uh, so now we, I would like to I would like you to draw attention on the landscape or the space industry, how we can divide that, who all are the players, so which area that people like you can associate with, right? So basically, it is divided into these four segments. So I will start from here. This is called upstream. Upstream means launch vehicle manufacturing or satellite manufacturing. So anything related to launch vehicles, satellite belongs to this particular category, along with the ground station support, things like that. Now, in midstream, it is a services for launching, access and operation. So basically, like in satellite data acquisition kind of thing, ride share opportunity, like there are, so how it works is, like suppose SpaceX is having their vehicle, so they will give to different brokers. They are called launch brokers. So they sell space to companies, satellite companies, right? So that is how it works. So that will happen in the midstream. So we were working with a broker. I'm just using the term broker called Exo Launch. So Exo Launch is one of the broker of SpaceX, and we were in discussion with them to put our satellite into their deployer system, which was integrated to the Falcon 9 rocket. So there are a lot of brokers. So brokers sell space of the launch vehicle to different satellite companies. Now, what the satellite company will do? They will use dedicated satellite for a dedicated mission, or they can also sell space. So they will also become a broker. So in our case, Nila, so we sold part of space to a German company. So that is, they call it as the first ride-sharing mission from India. So so they approached us in October. I will tell that story. So that is how it started. So it's basically a real estate business going on in very simple terms, okay, of millions. Space in the rocket as well as the space in the satellite as well. Not in the space. Pardon? Not transponder. It's the area or the volume that they are selling. So you can put anything what you want to put there. Okay. So I will come to that later. And downstream is where a lot of things happen. So we'll be getting a lot of data from these satellites, and this data needs to be processed for, like data should be accumulated, it should be treated, right? Then it will go one layer up. Finally, it will give insights, right? So that data layer will be there. Some kind of processing of data will be done. Finally, this data will be turned into insights. That itself is a huge business. Okay, so there are a lot of companies in India now. They are registered for downstream applications. So this is one area that people can look at, like where we can use machine learning, AI, a lot of techniques to come up with insights from the data that we receive from spacecraft. Anybody can do that. Only thing is, so you need to have data, right? Yeah. So that's the problem. But there are open sources which provide data. But anything, so if it is an Earth observation data, so anything less than 5-meter resolution, you need to pay for it. Even ISRO is providing data through National Remote Sensing Center. So you can log into that, you can get the data, you can work with that. Or Landsat is a NASA mission, Landsat. It also provides a lot of data. So data is available publicly, and there are a lot of companies who are working on this data and providing insights because of the development with respect to AI/ML. Okay, so the insight, they can look in from different perspective to generate insights. So this is a big market, and I think this will be one area where, as a country, a lot of companies will be coming in and will be providing a lot of applications. Okay, so pardon? Yeah, we can, we can. Not from all satellites, but for the selected.
cosmic plasma and changes. Uh, so the thing I want to know that which are all the material you prefer to mount that photomultiplier tubes that for the
Material.
material, yes.
Yeah, I will come to that, sir.
Yes.
Yeah. So basically, like most of the material that we are using on spacecraft will be aluminum, titanium, kind of. Titanium is not used for this class of satellite, but aluminum is more. For the structure is aluminum, right? And we are also using a composite in certain cases. Um, like PEEK is on material that is used for low cost thing. So there are a lot of materials. So material science itself is a area where a lot of research is happening on. And also for this site of this class of satellite, it is slowly moving from the subtractive manufacturing technique to additive manufacturing technique, like with 3D printing, right? So their material plays a major role. So a lot of materials are being researched. Currently, we are in discussion with MIT-based spin-off. So they are making a material which is for batteries. Okay, so that will improve the safety of the battery and also the power density of the battery. So this thing got this particular technology is granted by Tesla because they work on battery. But the interesting thing is this has got thermal insulation property and a radiation absorption property. So we are in discussion with them to get this material to understand how it can prevent or absorb radiation so that our electronics won't get affected. So a lot of things are happening on the material side. So we can discuss on that. Yeah, it's so if you look into telescope, like it has got different parts, like the outer thing, the optical part of it, the electronics. So everything matters. So I will just show you one company who are working on that on this particular thing. So downstream is the area like most of us have got access. Enablers, policy and regulation, like in India, there is an entity called InSpace. You may be knowing that. Indian National, it's for Promotion and Authorization Center. So they regulate everything with respect to policy in India. So if you want to send a satellite from India, and if it is an Indian satellite, we need to register this with InSpace. Then only it will become a Indian satellite. So on point with respect to that is, I have a question. Who owns space? Space means like outer space. Owns. Do anyone own space? I would like to know your response. Like, it's open to all. All nations have equal right to space, right? But there are spacefaring nations who are having a better access because of the technology what they are having, including India. Right.
Suppose Elon Musk established a base in Mars, and can any other country do the same?
We don't know that like how the policy is coming up. So basically, uh, like I was reading about this uh, from a legal perspective, what should be the rules of such an colonized part? like how should be the rules. So that is a topic of study or research by legal students in US. As a- so a lot of space laws is an area. Now only few people are there in India who knows about space laws. So we have one person in our company who knows space law because it is very, very important when we work with foreign countries to know the space laws. So we are more from a technical perspective. We don't know about law, right? So this is a very different industry. So I don't know the answer for that, but but this is what's happening. Okay, coming to like financing, insurance, these are all associated business because say on spacecraft it can a small one like a 3U, which will be say something close to 150K USD, to satellite which is tens of millions of dollars. So insurance play a major role. Okay, so when we went for insurance for Nila, so it's first time as a company we are flying. Uh, the insurance premium is half the price of the satellite, so we didn't insure at all. Okay, but for Indian spacecraft registered in India, it's an Indian spacecraft, right? So government of India owns that. So we need to sign a separate agreement with President of India. So he is the owner. Okay, if something happens because of a satellite, so as a nation, we will be liable for that, not the company. So from a legal perspective, there are different things. Okay, so that's itself a new like a different area. I am not an expert in that, but slowly studying because we are operating in this industry. Yeah, I'll come to that. I have a specific slide on that. Okay, so space domain awareness. It is mostly with respect to you are having a satellite. What's happening around that, or in space as a whole, the space domain, like how it is behaving, what are the different entities there, how it is moving. Those things all play a major role. We'll get into that later. So this is the ecosystem. So there are a lot of companies working in this area, companies working in this area, lot of companies in this area, and few enablers. Okay, so this is the space industry in a nutshell. Okay, any questions? Yeah, they'll be upstream and downstream as well. They also process their own data as well, right? Upstream, ISRO will be on upstream part. You have the UR space, UR RAU space satellite division. They are also upstream because they build satellites like INSAT, RSAT, INS, those kind of satellites. So they operate in these two areas. And midstream, yeah, yeah, I will come to that figure later. One company is Skyroot, another one is Agnikul. You know about Agnikul, right? So they started here in Trivandrum. They first started here in Trivandrum, then they moved to Chennai. So still the space is here in Tejaswini. Oh, Tejaswini, right? Here. Here they have a space. Yeah. Okay. Okay. So why many people are into space? 2033. These are figures taken from InSpace as well as from Bryce Tech, Nova Space thing. So if you look at in 2033, the market is close to a trillion, close to a trillion. And Indian government or India has set a goal to achieve 44 billion out of this. Okay, that is why the fuss is. Okay, so currently we are only 8.4 million of the current economy, current market, which is only 2% of the global space market. India plays only 2% of global space market. Why? Because it is done by ISRO. They are focusing on missions of scientific thing, national security and exploration, not on the commercial thing. They are doing it, but limited. Okay. This is what is happening this year, that is 2024. Close to 2,873 satellites were launched. The big number, right? And close to 200 launches were there. Out of that, you can see ISRO 5 launches. Okay, on 34 launches. Okay, so
Usable runs,
yeah,
right?
so they are having on 34. You know this player, like this is Rosmos. This is a Russian, China, and then comes others. Low Earth orbit and geosynchronous. 84% is in low Earth orbit. Okay, and if you look at the industry market for small sat, it is 80 billion in 2033, and close to 14,000 satellite will be launched. Now it is 2,873. Okay, so these are the figures, and what government of India did is they opened the space industry to private players. So they call it NGE, non-government entities. So all private players or whoever it may be, academia, everything is non-government entities. So that is why a lot of companies are setting up their centers here in India, working in different areas, and we are getting projects or missions, and a lot of investment coming in. So that is why it is still booming. Okay, not only in India but in other parts as well. Yeah. So that this is a commercial market. It doesn't include any defense part of it. It's 348 billion worth of downstream business in 2033. Data, yeah, and different application. I'll give few examples towards the end of this particular session. So this is where we stand. So that is why this is pulse, and there is one more term called new space and old space. Old space is like conventional government institutions like ISRO, NASA. They are called old space, and new private companies are called new space because of few things which I will, yeah. So this is in a nutshell about the space industry as such, like and the market potential. So a lot of things are happening there. Now coming back to like what now the next part of the session is what we are doing as a company. Okay. So this is Falcon 9 rocket. So it was launched in 2025, and you can see that our satellite is here. Okay. Okay. So actually, we were working on the technology for the last 1.5 years, 2 years, and last October or September rather, a company from Germany came to us and asked whether you can launch their payload by March. So they put that, and if we are ready to do that, they are ready to give the payload to us at a cost. Okay. So normally a satellite building will happen from say 12 months to 24 months. 4 months is a very, very tight schedule. Okay. So we were a bit bad on that. We took that opportunity because for us to survive, or we need to show something in space. Otherwise, a satellite company cannot survive. Okay, and it's difficult to get um, funding. It's a capital-intensive business, so it is difficult to get funding. We need to prove our technology in space, so it was very important. So we asked the team whether we can do it. They said yes. Actually, I was not much into that decision, but they said yes. So we went with the team. Uh, that's why I call it a little bit of madness. Okay, but the passion of the team was really there. It is not only the team of X20, because why we were able to complete this in on time if you look at in Trivandrum, there are 50 plus companies who are working for ISRO. 50 plus companies. And they are working as per ISRO standards. Okay. So you have a lot of things here which you can tap into. Okay. So once we design it, it can be get manufactured by local companies here in Trivandrum at the standard which is set very high by ISRO. And there are a lot of companies in Hyderabad, Kochi. So we work with close to 20 companies to make this happen. So supply chain managing 20 companies within 4 months is also a difficult task in addition to the work what we are also doing. So it's a real challenge, but somehow it came off. Okay?
So just before getting into that, we just want to know that how did you came into the space? That I think that is pre-COVID you started, right? The company. So can you tell us a bit about that?
Yeah. So this company is founded by 5 people. One person, Dr. Amal Chandran, he is in the US and he is in space industry for the last 20 years. So he is working in Boulder, CU, called a lab called LAF, which is the biggest lab outside NASA, and it's a spin-off from Colorado University. Okay, but it's working as an organization. So their budget itself is 300 million. That lab budget. So he's looking into the small satellite program. So he has done close to 20 missions. So he's the guy who has connect in space industry. Actually, we were discussing this 2017-18 to form such a company, but didn't took off. But in 2019 or 2018, like there is a big expo here in Trivandrum called the Space Expo, which was one of the first in the nation to start, but unfortunately it didn't kick off. But that triggered us to like register this company. Then COVID came. Then we started in Australia. Like we got some few projects. We got a project from NDU, Singapore, to write the flight software for the satellite. Small projects. Then the UAE thing, which I mentioned, came for us. Then we started here. Okay, that is how it all started. And all the founders are classmates. We studied during our engineering, so we were classmates. So we know each other for a long time.
Sorry for being stupid, but what does the satellite do?
Yeah, fine. I was expecting that question. It's not a stupid question. Okay, this particular satellite, right? It does two things. The mission of so every satellite should have a mission or objective should be there. So the objective for this particular mission is to prove our technology, which include a lot of things like from power generation to computers, onboard computers, to attitude determination. A lot of things are there. In addition to that, the main objective was the objective for our customer. Basically, they are having an actuator. It's a small actuator, which is shape memory based. Okay, so what it does is it will actuate in such a way that the solar panels can get deployed. Like you have seen that, right? Solar panels are normally stored to the body of the satellite. It will get deployed. So for deployment of that, you need to use actuators, and also antenna needs to get deployed. So antenna will be wound or maybe in a different will be within the body or close to on the surface of the body. So once it reaches space, it needs to be deployed. So for that, we need to use actuators. So the mission objective is the qualification of that actuators in space environment. So that's the mission objective. Okay, so to prove our tech plus this one. I will come to it. Okay, so this we make platforms. It is called satellite platforms. A platform is nothing but you can compare it with a truck. Okay, so it's a truck. So what's the purpose of the truck? To deliver something. So you put a container on top of it. It will go from one place to another. then it serves the need or the requirement, right? So for us, we are like a truck. We make the platform, which is called the satellite platform. The load or the container is the payload. A payload determines the behavior of the satellite or the function of the satellite. But for the payload to function, you need to do a lot of things. You need to generate power, you need to store power, you need to have data handling, communication, a lot of things. I will come to it later. Pardon? Control, yeah. So, so this is the platform what we are having right now, today, 8 series. We started working on a high performance 35 kg series. So this will be, this is planned for Q4 next year. So we will be launching it from, again from SpaceX, most probably from SpaceX. This is our vision for 3 years down the line. Okay, we need to migrate to this platform. So this is a sweet spot, like if you can operate in 150, say from 70 to 150 kg, then like we can tap into the market. So you know, like 14K satellite. So a lot of that falls into this category. So that is why our tech also needs to scale and reach there. So a lot of investment is required, and a lot of manpower is required.
Talent is required.
And
That is what,
talent is required.
yeah, expecting from the next generation here.
This one, like the current one, we had only one payload, which is the, pardon? Yeah, I will come to that. So these are the electronic systems that, this is the first version of it, not the right picture, but you will get a feel of it. Okay, so EPS means electrical power system. PDH means communication and data handling. COM is communication. These are solar panel, and so I will come to it later. So these are getting refined and refined for the next generation of satellite. So basically, the whole idea is something like a software configurable platform. So you may be hearing about software-defined vehicles, right? SDV, which is in automotive. Similar concept, but in a different way. So that is software-defined satellites platform. Okay. So a lot of software gets into this. Okay. So we are looking at the architecture for the software. It's not like the conventional satellite development, because when new players come in, most of them think differently, and new architecture comes. It's like on a while back, Tesla disrupted automotive, right? So a lot of disruption is coming in. So now, so many people ask, like, what is a platform or what it contains, right? So this is the telescope. So this one is the telescope. Okay. Basically, it is not it's not a telescope. It's a visible. It's for Earth observation, and also for sky observation. Basically, the purpose is to um, it's for space, like point you asked, domain awareness. Basically, it will be used to detect the debris. Yeah. So that's the optical payload. But the telescope is also there. And that's for star tracking. That is not included in this. But if the it depends on the payload mass and volume, like how much payload you can incorporate. So suppose if you take a small, not small, 1 meter cube spacecraft, uh, which will be close to 50 kg. 15 kg will be for the avionics and structures and other stuff. 15 to 20 kg. Rest can be for the payload. So, pardon? Hmm. Right. So, yeah. So, this is a small class of satellite. So, on the telescope kind of big, if you look at STAR, which is which is a bigger payload, the power requirement is close to 1 kilowatt, 2 kilowatt. So here in this case, this power requirement, if the power generated is only 80 to 100 watts here. So it varies based on the class of the satellite. So depends on the configuration. So we can operate up to 200 watts. As of now, we can operate up to 200 watts. That's it. Sorry. So there are 7 subsystems in any satellite platform. Okay. For the mechanical engineers, it is the structure and the thermal part of it, thermal management. So that's mostly a mechanical kind of activity. And also the mission planning can be done by mechanical students, like mission planning in sense like what orbit should take, like those kind of things. A lot of other things also come into picture. That is, mechanical and structure are 2 elements. Then we have the avionics, onboard computing. That is the 3rd thing. Communication, 4th thing. Propulsion, 5th thing. Attitude determination and control. That means you need to control your satellite, right? For example, like you have the payload here. You say camera. Assume this is a camera. So it needs to look towards the Earth. So you need to orient your satellite towards Earth. For that, control system is required. So that control system is called attitude determination control system. Okay. And sometimes you have to turn your satellite in such a way to tap more power. So the solar panel needs to be faced towards the sun. Okay. So again, attitude control is required. Now propulsion is required, like you're orbiting, right? Suppose we'll be getting sometimes we'll be getting conjunction data message, CDM. CDM means it's coming from US, there's a entity. There is a 0.02 probability of collision of your satellite with another satellite. So that conjunction analysis is done, that is what space situational awareness means, is done. If there is a collision probability, they will intimate us like there is a probability of collision. Then what we need to do? We need to maneuver or change, we need to avoid the collision. For that, propulsion is required. That is one use of. And we are operating low Earth orbit, right? Even though it's space, still it is having some matter, which will impact a drag on this spacecraft, and slowly the orbit comes down. So again, the orbit needs to be maintained. For that, propulsion needs to be used. Now, after the life of the satellite, we need to make the satellite re-enter the Earth atmosphere so that it will burn out. Again, for that, propulsion is required. So propulsion is required for many things. Okay, so that is a critical part. But the satellite which we launched didn't have any propulsion at all. Okay, pardon? Pardon? Geostationary, anyway, propulsion should be there.
Based on the same platform, instead of the telescope, if I want an equipment to capture the cosmic background radiation,
Yeah.
what changes should be made?
So this will be removed with your payload. So all these things remain same.
Only the telescope will be changed.
So how effectively and efficiently you can do it, that's the thing that we need to look at. With minimal changes, you should be able to do that. So we are in discussion with a customer to have a 3D printing machine with the satellite. So once it reaches the space, it will print. So actually they are trying to print an antenna road. So that technology needs to be validated. So we are in discussion with them. So these kind of requirements will come in. There are different kinds of propulsion. Chemical is widely used. Iodine is used. Xenon gas, when it will be turned into plasma and will be ejected through a nozzle. Electric propulsion is there. Now we are in discussion with a company for water propulsion. So they have made a water propulsion system which they want to validate in space. We are in discussion with them. So water will be stored at low pressure, and it will be heated to make it change the state, and will be uh, injected through a nozzle at a high velocity. So that is how it works. But it's a difficult control system that they have to look at. So a lot of propulsion. It's 10 bar, which is not very high. Sir, I don't know about it. It will be difficult, but I don't know about it. Pardon? So it is designed only for 6 months. It will become a junk, space junk, and debris, or the right word is debris. And in 3 years, it will re-enter and will burn. Re-entry, yeah. It will take 3 years. For that, you need to have propulsion unit. Yeah. So this is calculated with the altitude and the drag coefficients, like how long it will take to re-enter. So that's a different calculation. So that is where physics plays a major role, right? So in your area.
So a bit ago you mentioned like we are not having any propulsion unit in your satellite.
Pardon?
So you mentioned like we don't have propulsion unit in your satellite, which you launched. So how you are going to take it back to the?
Naturally, it will re-enter because of the drag in the.
So that's your plan. Right. Okay, sir.
So we cannot have a satellite in orbit which is higher than 600 kilometers. It should be less than 550 kilometers. Then only within 3 years this will happen.
Okay.
Otherwise, the regulatory body won't give you the permission.
Like, do you have any novel or unique idea from your company to make this even better?
Yeah, so we have a roadmap. So I'm not showing it here.
In high orbit, there are satellites, right? I don't know if this is a stupid question, but there are.
All questions are right.
Okay.
Answers can be stupid.
Okay. So there are satellites in high orbits, right? So they also will run out of life at some point of time, no? So there will be a problem of junk in space, right? How do we manage that?
Yeah, in higher orbits, there is an orbit called graveyard orbit. So you should use the propulsion system to put that spacecraft into the graveyard orbit.
So it's safe there. It will stay
So
there for the.
it's a junk. It's an orbit of junk debris.
Thank you.
It will completely burn out. It won't reach anything. Won't reach here.
In the case of that 150 kilo, right?
All these things, right? All satellites will burn. Nothing will reach here.
The engineering challenges, we need to have a satellite, even a small piece, actually reach the surface of Earth. What is the approximate size it needs to be? Thousands of kilos? What is the order?
I'm not aware of that. So maybe she may be the best.
Okay.
From physics.
Did you get the question?
Yeah.
I
what
was wondering.
What should be the minimum size of the object? If it re-enters, it should reach Earth.
I mean, I'm not asking for an exact weight, but just as a order, is it like 100 kilos, 1000 kilos, 10,000 kilos, or 100,000 kilos, so that it will have some probability that it will actually, even a grain will actually come and hit the, the planet, surface of the Earth. Wherever, just so that it will not completely burn away. Any 100%. Yeah, still, there should be some sort of a.
Yeah, your question is valid. I don't know as until
Because,
right now.
for instance, the meteorite that actually completely took away dinosaurs, if I remember right, it was the size of Manhattan.
Hmm.
It's massive. So what I'm saying is there are other meteors, very small ones, something that we can carry in hand that actually falls on Earth naturally. So what would be its actual size? Since
I don't know.
probably is
I
it
don't know.
thousands of times bigger?
Basically, if you look at sat,
Yeah, for instance, to understand what is the potential size at which we need to actually engineer for.
I'll put that. I will try to look that question from a different perspective with respect to satellite. So you're telling about a meteor which is
Huge.
huge and completely, it's massive, right? Homogeneous kind of substance. Like satellite is not like that,
Sure.
right? Yeah, yeah.
Still, still, is it ഒരു order കാണണ്ടേ? ഒരു order കാണണ്ടേ? Is it like 10,000 kilo?
Mic for him.
Is there any involvement for avionics once we reach the outer space?
Yeah. So avionics plays the most critical thing, right? So all systems are controlled by avionics, right? So that there will be flight software running in your onboard computer, which will be controlling a lot of things. When your payload should, there will be command coming from this ground station that needs to be processed. Sometimes payload needs to be turned on based on battery voltages. You need to decide the mode of the spacecraft. So a lot of things needs to be done. So it plays a major role. Okay. So we build satellites. That's the summary of this slide. Okay, this is our lab. It's a very small office, 1,000 square feet. 600 square feet is lab. So is this is a laminar airflow machine where we do the integration of satellite. This one. Okay. This is how we make a satellite. Like there are different steps in assembly, integration, things like that. Finally, once you make it, it will be something like this. Okay. And after this, we need to test. Okay, whether it can survive in this space environment. For that, we need to do different kinds of testing. Two tests that we normally do is a thermo vacuum testing, where the temperature will be varied for 48 or 72 hours from say minus 40 to plus 100 kind of thing. Temperature cycling will be done in vacuum, and you will be operating your payload in between and the systems and see whether it's functioning as expected, whether outgas thing is taking place. A lot of things happen. So after that, then we have to do the vibration testing, because it is fitted to a launch vehicle. You know the vibration of launch vehicle. So the whole idea is the resonant frequency of the launch vehicle should not match with the spacecraft resonant frequency, right? So that needs to be tested. So they will give the specification for the vibration that we need to do, like 10 Gs of vibration, which will be done, Gs of vibration in different axes. So that needs to be done. Then we need to analyze how the system behaved during the vibration test, whether it's operational after that. A lot of things needs to be done. And this is the integration which is happening at the broker facility. So here you can see the deployer. So you need to push this, there's a process for this. You need to put this inside this deployer and the door will be closed. Once the door will be closed, then it will be taken and fitted to the launch vehicle. Okay. So that is the integration with the deployer. Deployer is nothing but once it reaches the right altitude, deployer deploys your satellite. It's a spring kind of mechanism which will be activated and the door will be open and there's a pusher plate which will push the satellite into the orbit. Okay. And that's it. So once we have the satellite in orbit, we need to have the mission center, or we control the satellite. You need to command it, you need to commission it through commands. A lot of things needs to be done. So this is our satellite center or mission control center in Marine Engineering College. Okay. It's very simple now, but I know people like you are there, so we are making it very secure. Basically, if you want to get an approval for the ground station as a service, we need to comply with certain security standards. So there will be perimeter kind of security, as well as for the network it should be local, there should be firewall and encryption. So a lot of things comes into play there. So it depends on the path. Like this orbit is so sun synchronous orbit. That means uh, local time here on twice a day, it will be visiting or it will be going through Marine Engineering College twice a day. It's 11 a.m. and 11 p.m. In between, we can't receive any data. Only if you have the it will store and it will replay. It will replay. So a lot of data with respect to the satellite functioning, like how your power system is working, what's the battery status, how current is. Right. That is housekeeping data. In addition to that, if you have an imaging payload, so you have to transmit the images to
Signal for 24 hours, but we'll get a signal for 6 to 10 hours where we'll be collecting and sending data.
No, the signals will be always generated by the sun.
Will be generated, but
transmitted to the ground, it will happen only when it passes through the ground station. Currently, we have only one ground station, right?
Okay.
But for this particular satellite, this is an amateur frequency, UHF amateur frequency. So a lot of amateur people are there. They are getting the signals all over the world. It's a UHF 435, 438. Yeah, that's
so he is into cyber security. Yeah. So what are you planning?
So of course I'll try to capture the signals.
You can capture the signal. That's it. There is nothing secured in that. It's a state of the space.
Now you also disclosed it's gendered that frequency of which is used in ham.
But for the commanding, you cannot do that. For the commanding, you need to go through this, and that is encrypted.
Like that can be intercepted and analyzed. What you are how you are encrypting, how you are sending the signals, and then what are the parameters for command, and then it is very easy.
Yeah, you can do that.
Yeah. So while launching this particular satellite, what was your objective behind it?
For this particular satellite? So we'll be getting revenue from this. Pardon? So basically, I will take this use case. So for this particular satellite, the power generation maximum is close to 40 watts when it is in sunlit path. So this satellite orbits the Earth in 90 minutes. That means it will see 15 days and night in our one day. So 50 minutes it will be in sun, remaining it will be in eclipse. Okay, so only during the 50 minutes it can generate power. So we should have a battery. Okay, so battery is rated, like battery is I think it's 52 watt hours battery which we use. That is only required for this particular application. If you want to scale it, we can do it, but it depends on the mission objective. Yeah, scaling is can be done. So maybe if you need more power, then we have to use a bigger satellite, and the panels can be deployed. Like there will be a double deployment. So one panel like something like this. So we'll open this like that.
You did the material, you assembled the satellite and the software. So what was the most challenging aspect of it?
The most challenging aspect for this particular mission was the regulatory thing, not the technical. There are a lot of technical challenges. It doesn't mean that technical
In
challenges.
amateur frequency, like that one which is used for ham, is not like it should not be encrypted. The traffic should unencrypted. Even if you go for encryption, it is not allowed in
It is
that
not
frequency.
in
Also.
amateur frequency. You cannot encrypt.
Ah yes,
It
yes.
should be available to the community.
Ah yes,
So
yes.
the beacon which we are transmitting can be captured in the amateur frequency.
So how you are going to plan it to encrypt?
So basically, there is a community called SatNox, where a lot of amateur players are there across the globe. We have registered in it. So a lot of amateur people are decoding our data.
Okay.
It's publicly available.
Also, in this frequency, there is no licenses.
It's not licensed.
Required.
It's an amateur band, right? 435 to 438.5. It's an amateur band. They're hobbyists. Like they will analyze some data.
There is one team in Kerala who is working on this ham. Like, yeah, there is one good team actually. Very old and good team.
Yeah. So many people are like now. I think people who are studying in communication engineering can take a ham license. Now it is easy, not like say I cannot say it, but you can even listen to something like Action Hero Biju, like that.
I already planned to write that ham license, like exam for ham license. There is one center in Trivandrum only.
Yeah, now you can do it online.
Yeah.
Yeah. So better do that. Okay, fine. So,
can I ask you just one question? What kind of orbits are there? The polar orbits or?
this one is SSO, Sun Synchronous Orbit. Sun Synchronous Orbit is an inclined orbit. So that the thing is like in the local time, it will visit the local place at the same time every day. It's adjusted like the vehicle trajectory and the solar vector will be perpendicular. So something like that. 11 a.m., 11 p.m. For the communication. Basically, it depends on the band which we are using. Currently, it is UHF band, 25 kilohertz. 10 minutes. 10 so you will have a pass. In this case, you will have a pass for 10 minutes. And it also depends on the inclination. Yeah, 10 minutes. So, like where the satellite is in the horizon also plays a major role. So, if it is in the horizon, like elevation is less than 20 degree, it will be difficult to get. But anything above 20 degree, we can get it. 60, 70 is very good. So we have a training program, okay, which we are piloting in countries outside India. We are just started working with Digital University to have this program here in Kerala. So we are offering it to Taiwan, Peru, US, like Tuskegee, LASP, Australia, and few other, Kuwait, UAE. So this we sell. This is also is a product. We are selling it. Okay. Now these are the missions in pipeline. NILA is completed. Now we are having NILA 2. These are the missions in what we are having. So I will talk about this one, SUFFER.
So just before that, that is you are there in Marine Engineering College, and I think there are students from Marine Engineering College should be here. So have you ever visited this, or is there a way where these students can come and visit? And what? You know.
Yeah, we should be there. Then we can visit. So now it is remotely controlled. So we can control from our office. So seldom we go there. But what we are planning to do is to have a group of interns who will be operating the ground station.
Okay. So interns we will provide from. Mueller will provide the interns for that. Yeah.
So maybe after that, you are having exams right now, right? Yeah. So your college guys said that people are having exam. So after exam, we'll identify 5 to 10 good students. So we'll be working with them to operate the ground station. Also, a lot of work needs to be done. Say, like we took a lot of time to set this up. Lot of difficulties we faced. So it will be a good learning for students as well. Okay.
And also, like what he was planning is like we are planning to have a faculty development program, like from different campuses, your campuses. If faculties are interested in space, we can have space clubs in each campus, and there can be 1 or 2 faculties who take the leadership and a student.
Yeah. So currently we are doing it with Barton Hill. So they are having a space club, and it is going on for the last 3 years. So this is controlled by the faculty and the alumni there, and each year few students will be enrolled into this club. So they are building a satellite. Maybe by next year or after that they will be launching it. Now we are in discussion with model school, +1, +2 students. They are also making a payload. So they want to have a satellite. We are working with them because then if that happens, that will be the first school from Kerala to launch a satellite, right? So we are supporting them.
Yes, towards the end of this discussion, we will be talking about that. That is how you can lead the space industry at Mulan also. Okay. Yeah.
Depends. Like for a 3U, 3U, 1U will be the payload space. For 3U, that satellite which I showed, right? 2U for the other things, and 1U will be the payload size, and so it can be 1.3 kg.
So 1.3 kg is the payload, and
Thrust
is the structural mass.
Structure, avionics, other things.
Okay.
1.3 is a max.
Yeah. Those things like if I want to go into the satellite business, in development of satellites, there is money, or in operations, or in the where?
Good question. I think it will be downstream because investment will be less, and if we can come up with a very good application, then there will be money out of it. So that is the least risky path of least risk. If you have a very good idea,
yes,
and if you can use the satellite data to come up with something very good, then you can generate a lot of money with that.
So first you have to understand the type of data that you can get and then identify the use cases.
Right. So building a satellite and a launch vehicle is a costlier affair. So we need to invest a lot to make this. Okay. So on satellite, how small it is, you need to spend at least 1 CR. So it is not easy to get. So Nila cost is close to 1 CR, and to launch it another 1 CR. So 2 CR. And half of the money is from our customer.
So like why instead of using ISRO's launch vehicles, you went for SpaceX? What?
A good question, because you saw that number of launches, there are only 5 launches. So the customer wants the launch to be in March.
Okay,
so there was no vehicle from ISRO at that time. So we went to.
Yes, sir. Thank you.
It needs to be. It needs to be logistic is very important. So we need to package it in the right way, and we use Pelican case for that, with a lot of like sponge, not sponge. There is a material for that, and you have pressure, like sensors as well at different points. So once we reach there, we can understand whether some shock has happened or not. If some shock is there, then 1 CR is gone. So we need to ensure that. Fortunately for us, we didn't ensure. We took that risk and nothing happened. It's true flight. Yeah. So we'll put our stickers, right? Fragile spacecraft inside. Handle with care, spacecraft inside. Launch launch vehicle? A small rocket. Yeah, small. I I don't know. No, we cannot. You need to take permission. Yeah. Whatever it may be, you have to take permission. So I know people who are testing using. Yeah. Yes. Yes. So data is the business. Uh, so we used to hear this from a VC discussion.
I am asking this
Yeah,
question
this is the
because
19th time I am hearing it.
no, this question was relevant because 2014 onwards there is a company called Team Indus in Bangalore.
Yeah,
so I started working there, and so many companies came: Pixel, Skyroad, Acnicool, and now also there are so many startups in Hyderabad, Bangalore, and Chennai. So how this Hex 20 is standing different from?
Basically, it is based on the tech, one part of it, on the modularity configuration. There are a lot of thought process that went into this. So technology is one differentiator, and also the we have business.
So paying customer is already there.
These are all our customers right now. So no startup in India have this customer list missions. They are still doing the technology demonstration. So that's the difference.
Okay. So you have the paying customers. That's the differentiation.
Very good question. So what do you think? What we like? We are working on the satellite platform side, right? So we will be collaborating with a lot of parties here, educational institutions, small companies. Like we won't be expanding our team to a say 500 people company. So our 5-year roadmap will be close to 150 people. But we will be working with at least 40 vendors and students. Okay, so we'll work in the local ecosystem. We are having partnership with multiple companies. So we want to make everything indigenously here in India. Now, if you look at only 50% is now made by Hex20. Now, rest of the 50% we need to integrate within a year and a half. So we are working with a lot of companies, not a lot, 3 or 4 companies in Trivandrum, Cochin, Bangalore, so as to make that tech. Then only we can survive in this industry. Okay. So we ask what is the differentiator. So we need to have all these systems in place. Then only we can control the. It's not only technology, like it's how you manage the production costs, the supply chain. A lot of aspects comes into that. And Team Indus, they did a really good job, but what happened is different story. You may be knowing that. Yeah. Still there, they are in use, right? Yeah. So now if you look at Dhruva, Pixel, XT Links, these are the major company working on this satellite platform. They are ahead of us, but we have the projects. So I would like to talk about only one project. These are all suffer. So this is a project with the UAE Space Agency. We'll be getting a contract soon. I can disclose it right now. It's an asteroid mission. Okay, and it's a spacecraft which is designed by lab for UAE, and we are involved in developing the impactor module, which is a 16U spacecraft for this particular mission. So we are completely designing the impactor module. So this will be launched early 2027. I'll come to that. So basically the mission is to visit 7 asteroids in the Mars, the asteroid belt, right? 7 asteroids, which means 7 Emirates. So UAE is 7 Emirates, so they will be visiting 7 asteroids, taking a lot of pictures, and science experiments are also there. So it will fly by Venus, Mars, Earth multiple times, and it will reach this asteroid belt in 7 years. Okay, and it will be there. And last asteroid which is called Justitia. It's a small asteroid, 55 kilometer radius. So there they will be deploying a impactor. That impactor is designed by Hextendi. It's now being designed by Hextendi. So this is a very big project for us. Now, complete electronics, including the attitude, like camera payload is coming from them. We have our own camera for that. For say, it's attached to the main spacecraft. Once you get deployed, we need to take a photograph of the main spacecraft as well. Yeah, yeah. Finally, we got this. There were three parties, and we got that order. Impactor is nothing but it's a spacecraft that will be launched to the asteroid, and it will hit there. Sometimes it may break, or sometimes it will remain there. Anyway, the no, only one impactor. Only for the last asteroid, the impactor will be there. Seven other the main spacecraft will be orbiting and will be taking pictures and some things. Yeah, only one impactor will be there that will be deployed to the last asteroid. Yeah, it will hit that. No, it doesn't take anything. It will remain there. Yes. Yes. No. Yeah, there are some indirect measurement using the communication. Like the mission objective is to get the photograph of that. Before crashing, it will be sending data to the main spacecraft, and main spacecraft will relate to Earth. So, huh?
It's a platform we are developing. That is, is it what is it? This adaptable with the launch vehicle?
Pardon?
No, that platform we are
Developing.
That is suitable for the payload of all launch vehicles.
No, it is designed this spacecraft will be connected to the mother spacecraft. So it is adapted only to that spacecraft, and the whole thing will be like fitted to a Japanese launch vehicle.
Right, that's it. Thank you.
Okay, and this one is a lunar orbiter. We have an MOU with them. It's a company called iSpace from Japan. They are lunar explorer company, and their Hokuto 2 mission is on the way to lunar surface, and it will be landing there by June this year. In the fourth mission, Hokuto 4, our satellite will be also there. It will be orbiting the moon. So that is the another very ambitious mission that is in pipeline for us. Okay, the future looks good for us for the time being. We are getting these projects, but we need to develop the tech.
Sir, any difficulty you are facing from government of India in like any kind of support your expectation is not getting fulfilled from?
Do you really want me to answer?
If you can, if possible.
If he can help, he'll do some hacking and help you out with that.
No, in this, basically, say the government opened this to the private players, right? So they want all the private companies to succeed. So their support in the space domain is good, very good. So we were able to register within 3 months. So normally, like how long it will take to get something registered, but they did it within 3 months, which is good achievement. And also, it is not only this, we need to register for the ITU license, or the telecommunication community, right? For the spectrum that we are using. That also needs to be registered. And we need to work with DGFT, which is the foreign trade, different ministries. So all of them worked for this particular mission. So we got very good support. You expected a different answer, right? Okay, so the support was there. Yeah, so when we started, we were two technical people and 3 marketing guys. Okay. Now 19, 5 marketing guys plus technical people. So I have a lot of experience in different working with different companies. Like marketing plays a major role. So how it works is you need to be there in the expos and conferences. It's a very small community. This industry is very small. Only few players are there, right? So you need to be in the right places, on right conferences, make contact, discuss, and get this done. And also, we have an added advantage because of our founder. So he is in the industry for the last 20 years, and he is a renowned figure in the space industry. So that is our added advantage.
And this Nila mission would have gave you much higher credibility that more people will be coming, looking forward for
like
you.
Earlier when we go and pitch to our customers, we say that we have a subsystem which is TRL9, which is proven in space. Then the first question will, is your satellite there out there? So we said that we are working on it. So these particular missions came from universities, right? So first 1-2 missions. Then now we have our Nila working. So now we are getting a lot of queries in last 3 weeks. So we cannot take all of them, but we are getting good traction.
I want to know what your technical background is and how you are contributing to this.
Yeah, my technical background?
Yeah.
Okay. So basically, I started my career, I did my engineering in CET, electrical engineering, and I started my career in R&D in hardware development. So I worked there for 2 years doing hardware, basically products. Then I switched to firmware development. Okay. I worked in firmware development for quite some time. Then I switched to application space, networking. So like on the TCP/IP stack. Then I got involved in developing Linux kernel for a new microcontroller from Renesas. So that gave me a lot of insight onto the lower layers. Then I switched to Tata Elxsi, where I worked for automotive and some aerospace, small aerospace projects. So in automotive, I worked in a lot of systems for JLR, for BMW, a lot of companies. And I was fortunate enough to work for JLR research team in autonomous vehicle for 5 years. So we developed an autonomous vehicle here in Trivandrum. So it used to go around this campus 5 years back. So we had that technology then. Okay. So then I did my control engineering. So I'm a control engineer basically. And then I turned into system engineering, like in automotive and some small aerospace projects. Then I moved into robotics. So I showed that video. So I worked in robotics as a system engineer. Then I moved to this space. So basically, I don't have any previous space experience, but yeah, I'm studying it for the last 4 years and doing a lot of courses. So I'm building some part of it. So
Everything online.
Online discussion with people, discussion with team. A lot of consultants are there, so we are discussing with them. So
you sounding our version of
kidding. If you have the attitude to learn, we can learn, right? That's the only thing that matters. I mean, nowadays, I don't remember things. I need to write a lot of notes. Okay, so these are the missions. Okay. Do we have time? Or
15 more minutes.
yeah. where we are heading to. So this is generated by AI, and this tool is napkin.ai. I gave the points. It made a good picture today. He was asking for the slides, Ajoy. So I said I need 1 more hour. So earlier you see the quality before, like I was writing it down, right? And here I didn't have enough time, so I used AI. Okay. So I gave the points. It generated a beautiful map. Okay. It's, and the tool is napkin.ai is really good. Okay. Free. Okay. So he asked about like space sustainability. That's a major topic of discussion. Maybe you may be knowing a company called Digandara. So they are into this. It's an Indian company. They were working on space situational awareness. They are developing their payload, and so basically they are monitoring the LEO orbit from ground as well as in orbit. So their first satellite, I think, 2 satellites they have already launched, Scott 1 and Scott 2. Now they are making it bigger. Okay, so that is one company in India who is working in space sustainability or orbital debris detection. A lot of things are there. So this is one area. Commercialization of space, I think I touched that. In-orbit servicing, like this propulsion system, it can be refueled in orbit. So there will be some spacecraft having this fuel, so you need to dock with that, then refuel it, a lot of such concepts. So if you look at, like if you want to know more about it, you can look into InSpace City. InSpace City is a Mumbai-based startup, and they are exactly into this domain. And you can also look at a Space Dawn, which is a French company, also doing the same thing. There are many other companies. I'm just giving you examples. If somebody is interested to look into that, you can do that. Okay. Then small satellites we discussed. Lunar economy is a lot of things based on lunar, very ambitious. So how to get helium-3, power beaming, those kind of concepts. So Hakota or the iSpace, they are focusing on lunar exploration. Okay, to make colonies there. And constellations, a lot of constellation players are coming in. Starlink, OneWeb, Kuiper, and there are many others. And even in India, there will be satellites in future, like Reliance. We don't know. This may be of interesting topic to AI and autonomy in space. Most of the systems now is controlled through command, especially in autonomous part is there. But how we can make it more autonomous from a space mission point of view. So a lot of AI elements are coming into this, but you are using telescope, you are using optical camera, thermal images. So a lot of ML, AI algorithms can be used for image processing and things like that. So that is one area that a lot of people are looking into. And a lot of startups coming up, especially in developing countries. Like if you go to Thailand, Peru, actually last week we were having a discussion with Peru. We had 2 engineers working with their engineers in Peru. They want to build a satellite. So a lot of such things are happening globally. So the market is there, but we need to take the right steps. Coming to space domain awareness, this is one area that I want to give some insight. So he asked about it. This is how the LEO orbit looks like. Okay. So if you look at, there are, as of March, 11,833 active satellites are there. 84% is in LEO. 84% of the satellites are less than 500 kg. From 1957 to up today, or maybe till March, there were 6,890 rocket launches, successful rocket launches or launches. These launches contributed to 21,320 satellites and 13.9 K tons of matter is there from Earth orbiting there. Okay, You can see there are red spots here. These are debris. Okay. Now, different entities are tracking debris of size more than 10 centimeter. There are 40K such debris, 40,000 debris, which is 10 centimeter or more, orbiting around the Earth. And if it gets in touch or if it collides with the satellite, damage will be there, right? These are orbiting at 7.2 kilometer per second. So the energy associated with this very high, right? Yeah, they are not bringing it down right now. There are plans like that, how to bring it down, but there are people who are currently focusing on tracking it. So if you look at this red thing, right, these are image radars. This is from Leo Lab. This is a company called Leo Lab who does that, who provide this information. I took it from their website. Okay. And right. But yeah, so different crazy ideas are there. Sometime it will happen soon. And if you look at less than on 10 centimeter, 1 centimeter to 10 centimeter, it is 1 million. And less than 1 centimeter, it is 130 million. 130 million. Pardon? No. Just like out of these satellites, 85% is less than having a mass less than 500 kg. Pardon? How? No. That's huge. Not 500 kg. So this is space situational awareness. So a lot of companies are taking this data and they are using techniques to predict the path of the debris. It's not spotting it. There's a lot of challenge associated with it. 10 centimeter debris, you need to find the orbit of that particular debris. Then only you can say that this will collide with your orbit or not. So how will you do that? So a lot of satellite can only follow an orbit. Orbit can be changed.
Suppose if we can have a satellite robot which can clean the debris,
Yeah,
kind
there
of.
are a lot of ideas coming like that.
Okay.
With a net, with robotic hand, many satellites carrying a net like this, like a fishing net, kind of thing. So many ideas. Okay. So if we can come up with something good, maybe a good area. So you just have to think about like the velocity at which this is going, right? 7.2 kilometer per second.
Sir, one more question.
But one more point, we cannot shoot it down, right? That is not possible because again you will be generating debris. That will again cause it's like an avalanche kind of thing. So you cannot do that. Okay.
I have a
Or you have to
question.
fully burn it. If possible, think about it.
Sir, I have a question.
Sorry.
Very small. What kind of payloads are not allowed by SpaceX? And like, why I'm asking, because maybe if one startup is there who is working on intelligence, what kind of payloads are there in other satellites? Like yesterday, I got that question from DSCI team. So they were asking, like, is there anything by which you can identify what kind of payloads are there in, like maybe in other countries' satellite, so that you can gain information, and then based on that we can also develop such kind of technology, or at least to identify what is their goal or what is their inside thing going on. So
Yeah. So basically, there will be different surveillance kind of satellites doing this kind of things.
yeah,
We are not into it.
no, just one thing, like, is there any restriction from a SpaceX that this
Actually, it's a process. Like we need to provide a lot of documentation regarding the satellite, each part of it, what's the payload, those specifications, they will review it. Yeah, a lot of, it's a process. It's a process, and this goes to them. They will be seeing it. So
certain things that we are not revealing to them.
Yeah,
if we are like,
they are
I don't
only
know.
one launch, like they are only providing me service to deliver my payload to the space. There is nothing to do. What is my business now? Is there any risk
There
like
may
that?
be some mafias like that who can do this.
No, anyway, I am involved with the government. If suppose if you're launching, then you have already signed with the
Basically,
President of India.
I don't know about it. I'm not the right person to answer that question. I don't know about it. Like, so
Okay,
on,
sir.
like once you cannot send a satellite before registering, right? So if you are registering in India, they will look into all aspects of your satellite.
Mm-hmm.
So whether India government will allow.
Yes, yes, of course. Maybe for surveillance purpose, I am
For
launching.
spying, they won't allow.
Yeah.
Surveillance we can do, but like and also it depends on the payload, ground separation distance, or the resolution part of it. Something below 5 meter, then different route, different like we need to have application for that as well. So it's a tedious process.
Okay, sir. Understood. Thank you.
Pardon?
Program.
Clip.
So X20 is applying for that?
No, no,
No, not yet.
no. Okay, these are some use cases that just for you, like if you are working on data related, these use cases are taken from a Saudi challenge. The challenge is still open till 14th of this month, that is Saturday. If you want to put some idea into that, you can do that. Some wild ideas using satellite data. The challenge is there. It is a 28 million challenge from Saudi government. Okay, anybody can apply for that. So I took that. So these are some there are hundreds of use cases. No, Saudi. These challenges are from Saudi. Basically, it is related to urban planning, vegetation monitoring, the quality of the vegetation, aerosol detection, greenhouse gas monitoring, a lot of use cases. Your traffic flow monitoring, even pothole monitoring, many things. So if you have data and if you can come up with a solution for this, then somebody asked you like how to make money, right? Pardon? Japanese? I'll say like we can use their launch vehicle as well. Like, yeah. Pardon? Japan.
Yeah. So last 2 minutes, and any other questions can be taken offline after this. Yeah.
So last, I want to
Yeah,
show
you just conclude. Yeah, that's
this
fine.
slide. So a lot of training programs, a lot of materials are there for people who wants to learn about satellite and satellite technology. Courses are there from different university. So here, what do you say? Like now, if you see in India, many colleges are having space club. They are trying to make something by their own. There are few companies Space Kids providing training. Now, if you look into Coursera or Udemy, there are courses for satellite building. So, like a lot of materials are there, and like we can do a lot of things. And say NSIL or in space can take college satellites into space without paying. So if you can make a satellite, it can be launched with minimal cost because it is an academic project. So those options are also there. Okay, a lot of areas. If you want, you can take the photo of it. So in India, like I am just focusing on this one. there are 658 startups registered by March 31. When we registered, it is 53, that is 2 years back. Now you can see 658 registration in space, and 236 are satellite companies. I don't know what form it is. 89 launch vehicle companies. So a lot of competition, and only few will survive. And we are not thinking about that right now. One step at a time. Okay. So I think that's the last slide from my side. Okay. This is a total funding received by Indian startups, 380 million. This is grant companies, but there are 658 others waiting for funding, going for funding. So it's a bit tough.
And also it requires huge funding, not smaller funding. Yeah.
Mostly from private. Pardon? India and abroad. India and abroad. If you have a good idea. So that's it. Thank you very much. And if you have any more questions, I can love to take that.
Wow.
I hope the session is useful.
What a session, അല്ലേ? ഒരു സിനിമ കാണുന്ന പോലെ നമ്മൾ തുടക്കം തൊട്ട് അവസാനം വരെ ഇങ്ങനെ അത് കണ്ടുകൊണ്ടിരിക്കുവായിരുന്നു. And the types of questions, I really appreciate. ഇതിനകത്ത് വന്ന ക്വസ്റ്റ്യൻസിനെ കുറിച്ച്, ഓഡിയൻസിനെ കുറിച്ച് എന്താ പറയുന്നത്?
Normally, like when we talk to people in colleges, especially in this part of the world, like I used to do a lot of presentation to students. I don't get even a single question. In most cases, maybe one question if I am lucky. But here I saw a very good interactive crowd. You asked many questions, right? So it's really good. And normally you won't get that. So if I am speaking to a college in Bangalore, it used to be like this. But here, seldom we'll get a chance to have questions. That's great. Thank you very much. I don't know whether I answered it correctly for most of you. You have to refer again. Okay. Whatever. Pardon? Thank you. Thank you. Thank you. Okay. Thank you very much.
അതായത് ഓരോ പോയിന്റും ഓരോ ക്വസ്റ്റ്യൻസും കറക്റ്റ് ആയിട്ട് നോക്കിയിട്ട് എന്തൊക്കെ തരത്തിലുള്ള ക്വസ്റ്റ്യൻസ് വന്നു, ഡിഫറെന്റ് ടൈപ്സ് ഓഫ് ക്വസ്റ്റ്യൻസ് ദാറ്റ് കെയിം ഇൻ, റൈറ്റ്? സോ and I think this also, you have another question? Yeah, you want to say?
Okay, I would like to add some points also, and finally one question is there. So first of all, as they said, there are some satellites. Actually, most of the times it will be burned out in the atmosphere. And recently there was a Tiangong one. It's called it's Chinese word. Its name is Palace in the Sky. So it's their space station because they don't have any contribution to ISS. So they have came with their own. So last time they have deorbited it, and it went somewhere in the South Pacific Ocean, and that was nearly 8 tons of weight. So that case are there. And there are some places like these are the lower Earth orbits, and there are geostationary. So those satellites, there is some graveyard orbit which is more with it has more radius than the current geostationary. So that things are there. So and regarding this I have found that it's sending in the amateur radio frequency. I am an amateur radio operator, and I have tried getting the signal from the ASS, and I have searched for this frequency in the internet. I didn't get that, so I could not get the signal. So thank you that you said in the UHF frequency. Okay, we'll check that thing. And the next thing is you have shown some boards of that subsystems of the satellites, and I have seen that and it's my question. I have seen that there are command data handling subsystem and also communicate subsystems. So why two different subsystems you are using?
It's the onboard computer. So you can consider this as an onboard computer, command data handling. So small spacecraft, it does spacecraft the mode management, the housekeeping data, and activating the payload based on the command, and also sending the beacons through the transceiver. Yeah, so mostly if you look at the command data handling is the major functionality. So that is why it is called as command data handling. But in bigger satellite, we can call it as, there will be two such systems. One will be an onboard computer, which does a lot of other things, and you have a command data handling, specifically handling the command and the data housekeeping part of it. So that is the difference. So for small satellite, OBC and CDH is one and the same.
So normally we don't give feedback, but I know that at FAYA Board 80, most of after the session, that will give them a sense of fulfillment. That is whether my session was, how good it was, and then was it beneficial or not. So how many of you want to give some feedback about the session? Yeah.
ഹായ് സാർ, ഇവിടെ വരുന്നത് വരെ എനിക്ക് സാറ്റലൈറ്റിനെ പറ്റി 4 സെൻറ്റൻസ് ആയിരുന്നു അറിയാറ്. ഐ മീൻ സാറ്റലൈറ്റ് ഭൂമിക്ക് ചുറ്റും പോവും, പിന്നെ കുറേ കമ്പനികളുണ്ട് സാറ്റലൈറ്റ് വിൽക്കുന്നത്, പിന്നെ ഒരു സെൻറ്റൻസ് അല്ല, PSLV GSLV അങ്ങനെ. ഇത്ര എനിക്ക് അറിയത്തുള്ളൂ. ഇതിന് കുറച്ചുകൂടെ അറിയാം. ദിസ് ഇസ് വെരി ഗുഡ്. ക്യൂരിയോസിറ്റി മെയിൻറ്റെയിൻ ചെയ്യുന്ന താങ്ക്സ്. കാരണം എൻ്റെ ഏജിൽ ഞാൻ അത്ര പ്രായമുണ്ടെന്നല്ല പറയുന്നത്, ബട്ട് പക്ഷേ കമ്പയറിങ് ദീസ് ഗൈസ്, I think I'm not curious enough. They're asking the right question. I don't know if that's the right question to ask, but yeah, they're asking questions. I couldn't think of anything. Like, ഇതെന്താ സാധനം? Like, ഈ കുറേ റോക്കറ്റ്സിൻ്റെ ഫോട്ടോ കാണിച്ചില്ലേ, PSLV, SpaceXൻ്റെ. I could only say rockets. Like, കുറേ തീ കത്തിച്ചാൽ പോകുന്ന ലിറ്ററലി അതാണ് ഞാൻ കാണുന്നത്. Okay, but they're spotting the names of these rockets. So, yeah, I don't know. They know more stuff. This is good. I don't know. And college students know this stuff. Like in the kalatha, we didn't entertain such space talks in college. Like get a degree and get out. Like they know the stuff. This is good. So that's what it is good, sir.
It gave me a very good opportunity to interact with you, to start my work with you, and that I think that is we will succeed in this. Thank you.
So that also this is normally നമ്മളൊരു സെഷൻ വെക്കുമ്പോഴത്തേക്ക് വെബ് ടെക്നോളജിക്ക് ആണെങ്കിൽ ഇതിൻ്റെ ബാക്കിലൊക്കെ ഒരുപാട് പേര് നിന്നിട്ട് ഒരു 80-100 പീപ്പിളൊക്കെ ഇവിടെ നിറഞ്ഞിങ്ങനെ നിൽക്കും. But this is the cream of resources. That is who is really actually interested in space and then looking forward for that. And I think for sure ഒരുപാട് പേര് ഇൻസ്പിറേഷൻ ആയിട്ടുണ്ടാവാം to think about space startups and all. So Ekta traveled from Kochi just for the session, and I think tomorrow she has an examination. She has to go back.
Hi, sir. I reside in Ernakulam, right? And I want to tell you that traveling those 4.5 hours for this was absolutely worth it. My university exams are going on right now, and as a BSc physics student, physics theory പഠിക്കും, എന്നിട്ട് in the exam they'll end up asking questions like calculate the velocity of the chicken crossing the road and stuff like that. പക്ഷേ ആ പഠിക്കുന്ന സാധനത്തിന്റെ real life application that was beautifully explained, and thank you so much. That's all I have to say. This was totally worth it.
So thank you so much for the session. More than all of the knowledge that you shared, right? It is very inspiring to have companies locally, and then working with, I don't know how much resources you have, but I know that you started frugally, right? And you set up a station in a college where nobody would generally go to, right? It's not like CET or IIT or NIT, right? So all of that, I think it is inspiring a lot of people, whether you know it or not, right? And not just in space science, but also as I work in AI. And it also inspires us to do bigger and dream bigger and do better things. And thank you so much.
ജിക്കു മുങ്ങി നടക്കുകയാണ്. പക്ഷേ ഹരിച്ചേട്ടൻ,
as usual, it is very good. X20, actually, your accomplishment should be trumpeted a lot more because you have brought in a lot of new dimensions into what is happening here. And hopefully you will ignite a lot more interest and a lot more business to space community here. All the best.
ഹലോ സർ, എക്സ്റ്റൻഡിയുടെ ലോയുടെ പണ്ട് ഇത് തുടങ്ങണമെന്ന് ആഗ്രഹിക്കുന്ന സമയം പോലെ ഏതാണ്ട് പല കഥകളും പല ഡിസ്കഷനും കേൾക്കാറുണ്ടായിരുന്നു. ഇപ്പം നിങ്ങളുടെ ഒരുവിധപ്പെട്ട ലേറ്റസ്റ്റ് കഥകൾ പലതും ഞാൻ വളരെ ഫോളോ ചെയ്യാറുണ്ട്. അവിടെ നിന്ന് കേട്ടതിനേക്കാളും വളരെ വലിയ കാര്യമാണ് ഇവിടെ വന്നപ്പം പലതും കേൾക്കാൻ പറ്റും. പലപ്പോഴും നമുക്ക് തലയിൽ കൊണ്ടെടുക്കാൻ പറ്റാത്ത അവസ്ഥയാണ്. സോ കിട്ടുന്ന മാക്സിമം എടുത്തുന്നുള്ളതാണ്. ആൻഡ് ഐ വെരി ഹാപ്പി ദാറ്റ് ഇറ്റ് ഈസ് ഗ്രൗൺ ചുരുങ്ങിയ സമയത്തേക്കും ഗ്രോ ചെയ്തു. ആൻഡ് ഐ ബിലീവ് ഡെഫിനറ്റ്ലി വി ക്യാൻ ഗോ ഫർദർ. വളരെ ഹൈറ്റ്സ് എത്താൻ പറ്റുന്ന വിശ്വസിക്കുന്നുണ്ട്. ആൻഡ് ഓൾ ദ ബെസ്റ്റ് ഫോർ ദ ടീം.
ഇപ്പോൾ കഴിഞ്ഞ 3 ആഴ്ച കുറെ മെയിൽസും കുറെ റിക്വസ്റ്റുകളൊക്കെ വന്നു തുടങ്ങിയെന്ന് പറഞ്ഞു. ഇനി കുറച്ചുകൂടി കഴിഞ്ഞ് കഴിഞ്ഞാൽ നമുക്ക് ചിലപ്പോൾ ഇങ്ങോട്ടേക്കൊന്നും കിട്ടിയത് വരില്ല. അതിന്റെ ആ ഒരു ഗ്യാപ്പിനകത്താണ് നമ്മൾ കൊണ്ടുവന്നത്. ആൻഡ് ഐ തിങ്ക് ലൈക്ക് നേരത്തെ ചിലർ ഇത് ഇതുപോലെ നമ്മുടെ സ്വന്തം അയൺമാൻ ആണ് നമ്മുടെ അടുത്ത് നിൽക്കുന്നത് എന്നുള്ളതാണ്. So hats off to you and for being bold to take those type of massive steps. അത് 4 മാസത്തെ ഒരു ചലഞ്ച് വന്നപ്പോൾ അത് ഏറ്റെടുത്ത് ചെയ്യാൻ തയ്യാറായി അത് സക്സസ്ഫുള്ളി കംപ്ലീറ്റ് ചെയ്യാൻ കഴിയുക എന്ന് പറയുന്നത് ചലഞ്ച് ഏറ്റെടുക്കുക എന്നുള്ളത് ഒരു കാര്യമാണ്. പക്ഷെ അത് പ്രോപ്പറായിട്ട് അത് ചെയ്ത് ലോഞ്ച് ചെയ്യുക എന്ന് പറയുന്നത് ഇറ്റ് റിക്വയർസ് ലോട്ട് ഓഫ് സ്കിൽഫുൾ എക്സിക്യൂഷൻ, പ്രോപ്പറായിട്ട് ഡയറക്ഷൻ ചെയ്യണം, അത്രയും ടീം മുഴുവനായിട്ട് വന്ന് വർക്ക് ചെയ്യണം. ബാക്കി ഒരുപാട് ചലഞ്ചസ് വാസ് ദെയർ ഫോർ നോട്ട് മേക്കിംഗ് ഇറ്റ് ഹാപ്പൻ. ബട്ട് അതിന് വേണ്ടത് എന്തൊക്കെയാണോ ആ വഴികളെല്ലാം കണ്ടെത്തി ഇൻഷുറൻസ് പോലും ഇല്ലാണ്ട് ആ റിസ്കോട് കൂടി അവിടെ എത്തി സക്സസ് ചെയ്ത് ലോഞ്ച് ചെയ്തു. ദാറ്റ് ഈസ് യു മേക്ക് us പ്രൗഡ്. നമുക്ക് നമ്മുടെ നാടിനും എല്ലാവർക്കും അഭിമാനിക്കാവുന്ന ഒരു വൻ വിജയം തന്നെയാണ്. So I would like to call the FAYA Potity Committee. Ajay, yeah, a small token of appreciation. അപ്പൊ ഇതൊരു തുടക്കമാണ്. നമ്മുടെ ഫയ പോർട്ടേറ്റ് ഇത് 126ാമത്തെ എഡിഷൻ ആണ്. 2013 നമ്മൾ സ്റ്റാർട്ട് ചെയ്തിട്ട്. പക്ഷെ ഇന്ന് വരെ ആയിട്ട് നമ്മൾ സ്പേസിനെ കുറിച്ച് ഡിസ്കസ് ചെയ്തിട്ടുണ്ടായിരുന്നു. സ്പേസിന്റെ ഏതെങ്കിലും ടോപ്പിക് ഇല്ലായിരുന്നല്ലോ. ബിക്കോസ് വി ട്രൈഡ് മെനി ടൈംസ് ബട്ട് ഇറ്റ് ഡിഡ്ന്റ് ഹാപ്പൻ. മറ്റേ ചെന്നൈയിൽ നിന്ന് അവരെ നമ്മൾ കൊണ്ടുവരാൻ ശ്രമിച്ചു. അങ്ങനെ പല ടൈമും ഇതൊന്നും എന്നിട്ട് നടന്നിട്ടില്ല. ആൻഡ് ദിസ് ഈസ് ദ ഫസ്റ്റ് സ്പേസ് ടോപ്പിക്. ആൻഡ് ഐ തിങ്ക് ഇത് ഒരുപാട് പേരുടെ മൈൻഡിൽ ഒരുപാട് ഐഡിയാസ് സ്പാർക്ക് ചെയ്തിട്ടുണ്ടാവും. ആൻഡ് ദർ വിൽ ബി റിപ്പിൾസ് ഫ്രം ദിസ് ഫോർ ഷുവർ. ആൻഡ് നമ്മുടെ മ്യൂലേണിനകത്തുള്ള ടീമിനകത്ത് നിന്ന് സ്പേസിന്റെ ഇൻട്രസ്റ്റ് ഗ്രൂപ്പ് ലീഡ് ചെയ്യാനായിട്ട് താല്പര്യമുള്ള ആൾക്കാരൊന്ന് കൈവെക്കാവോ? So we will actually start a space interest group in Mulan, and there are certain activities that we planned forward with that. And if you want a continued session on space in coming month, what should be the topic? Because normally whenever we start something, that is, we will have a series of JavaScript LLMs. We had 3 or 4 sessions on that. So biomimicry technology. Payloads. So the opportunity with payloads or something practical downstream.
Kind of data, because that is something which with very little investment and even students can start. So that may be a good area to start with.
So today's session was to give you a generic outline on what is happening in space. അല്ലേ? എന്തൊക്കെയാണെന്നുള്ളത് ഒരു അറ്റം മുതൽ അങ്ങേ അറ്റം വരെ ഒന്നും നമ്മൾ മറിച്ച് നോക്കാണ്ടിരുന്നില്ല. എല്ലാ കാര്യങ്ങളും ഒന്ന് മറിച്ച് നോക്കി എന്തൊക്കെയാണെന്നൊന്ന് ഫൗണ്ടേഷണൽ നോളജ് സ്ട്രോങ്ങർ ആക്കിയിട്ടുണ്ട്. ഫൗണ്ടേഷൻ നോളജ് വെച്ചാൽ ഒരു ഔട്ട്ലൈൻ കിട്ടിയിട്ടുണ്ട് എന്തൊക്കെയാണെന്നുള്ളത്. ഇനി നമുക്കൊരു ഏതെങ്കിലും ഒരു മേഖലയിൽ ഫോക്കസ് ചെയ്യണം എന്ന് പറഞ്ഞാൽ ദാറ്റ് വുഡ് ബി ഡൗൺ സ്ട്രീം. Okay. So that will actually give a lot of opportunities for students to try up with things. And he actually said like there will be problem statements that we can come up with that can be thrown for the students in future. But ഇന്ന് തന്നെ ഒരുപാട് പ്രോബ്ലം സ്റ്റേറ്റ്മെന്റ്സ് ഒരുപാട് ഐഡിയാസും ഒക്കെ പലരുടെ മനസ്സിൽ കത്തിയിട്ടുണ്ടാവും അല്ലേ? എന്തെങ്കിലും പറയാനുണ്ടോ?
എന്തായാലും ഭയങ്കര ഇൻട്രസ്റ്റിംഗ് ആയിരുന്നു. എന്ന് വെച്ചാൽ പുതിയ പുതിയ കുറെ എനിക്ക് ഇങ്ങനത്തെ ഇൻഫർമേഷൻ ഒന്നും നേരത്തെ ഒന്നും കിട്ടിയിട്ടില്ല. ലൈക്ക് പുതിയ ഡൗൺ സ്ട്രീം എന്താണ് ഇന്ന് ആദ്യമായിട്ടാണ് ഇത്രയും ബില്യൺസ് ഓഫ് ഡോളേഴ്സ് കിട്ടും എന്നുള്ളൊരു അല്ല 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 അത്രയും വലിയൊരു മാർക്കറ്റാണ്. എനിവേ എത്രയും വലിയൊരു മാർക്കറ്റാണെന്നൊക്കെ ഇന്നൊരു സെഷൻ വന്നപ്പോഴാണ് മനസ്സിലായി. അപ്പൊ അതിലൊരു കുഞ്ഞ് ഒരു 0.5% ഒക്കെ പിടിച്ചാൽ പോലും എന്ത് വലിയൊരു എനിക്ക് ആ ഒരു ആസ്പെക്ട് ഭയങ്കര ഇൻട്രസ്റ്റിംഗ് ആയിട്ട് തോന്നി.
I also thinking about India in space, like for Kerala flood is happening, and tracking the rain data and hilly areas, we can find where which all hills have more water, like yeah.
Like last week, the different government bodies of Kerala, from irrigation, from like PWD, urban planning. So those departments have posted a lot of problems. Like how they can solve these problems using space data. So they had given these problems to InSpace. Okay, and they are coming down maybe towards the end of this month or May to have a workshop here in Trivandrum. So this will be open to maybe many people, students as well. So if that's an open workshop, it's better to attend that. You will get a lot of ideas like this thing, like what are the, like this point came up from the department. So close to 10-15 problems were posted by different departments in Kerala government, and something's happening there. Better focus on that. You'll get a lot of ideas if you attend that kind of sessions.
K-Space, Levin is you. K-Space, yeah. Okay, so നമുക്ക് officially close ചെയ്യാം. So Ajoy, അജയ് ഭയങ്കര ഷൈ ആണ്. അജയ് നോർമലി ഫോട്ടോയ്ക്ക് ഒന്നും നിൽക്കാറില്ല. കൊടുക്കും. അജയ് ആണല്ലേ ഇതൊക്കെ ചോദിച്ചത്, സ്ലൈഡൊക്കെ ചോദിച്ചത്. അപ്പൊ എന്തായാലും അതുപോലെ തന്നെ ഇന്ന് രാവിലെ ഞാൻ നമ്പി നാരായണൻ സാറുമായിട്ടൊരു ഡിസ്കഷൻ രാവിലെ ഒന്ന് എനിക്ക് സംസാരിക്കാൻ പറ്റിയ അദ്ദേഹമായിട്ട് ഏകദേശം ഒരു 45 minutes ഹി സ്പോക്ക് ടു മീ, ആൻഡ് ഹീ ഈസ് ഇൻട്രസ്റ്റഡ് ടു മീറ്റ് 2-3 നല്ല ക്വാളിറ്റി സ്പേസ് സ്റ്റാർട്ടപ്സ് ഉണ്ട് എങ്കിൽ, അല്ലെങ്കിൽ അങ്ങനത്തെ ഇൻട്രസ്റ്റഡ് ആയിട്ടുള്ള ആൾക്കാരുണ്ടെങ്കിൽ, ദാറ്റ് ഈസ് ഹി ഈസ് വില്ലിംഗ് ടു ഇൻവൈറ്റ് ദം ടു ഹിസ് ഹോം ആൻഡ് ഹാവ് എ ഡിസ്കഷൻ. ബിക്കോസ് പുള്ളി വാനം എന്ന് പറയുന്ന ഒരു ആക്സിലേറ്റർ പ്രോഗ്രാം ഉണ്ട് ഇതിനകത്ത് സ്പേസ് സ്റ്റാർട്ടപ്സിനായിട്ട്. So there are 4 segments that he mentioned, and we might be meeting him in person ഉടനെ തന്നെ. And സ്പേസ് എന്ന് പറയുന്നത് എപ്പോഴും കേരളത്തിനകത്ത് അത്രയും ഓപ്പർച്യൂണിറ്റീസ് ഉള്ള, കേരളത്തിൽ ഹിസ്റ്റോറിക്കലി അത്രയും പ്രാധാന്യമുള്ള ഒരു ഇതാണ്. നമുക്ക് IT ബിസിനസ്സും കാര്യങ്ങളെല്ലാം വരുന്നതിന് മുമ്പ് തന്നെ കേരളം അറിയപ്പെട്ടിരുന്നത് സ്പേസിന്റെ ഇതിനകത്തായിരുന്നു അല്ലെ. അപ്പൊ ഇലക്ട്രോണിക്സ് ആയിക്കോട്ടെ, അല്ലെങ്കിൽ ഇപ്പൊ കെൽട്രോൺ ആയിക്കോട്ടെ, ഇതെല്ലാം ഒരു ഹിസ്റ്റോറിക്കലി അത്രത്തോളം പവർഫുൾ ആയിട്ടൊരു സാധനം ഏതോ ഒരു സമയത്ത് നമ്മൾ അതിന്റെ പ്രാധാന്യത്തിന് താഴേക്ക് പോയിട്ടുണ്ട് എങ്കിൽ, നേരത്തെ കണ്ടില്ല ഒരു ബിസിനസ് ഇനി അങ്ങോട്ട് മുമ്പിലേക്ക് വരുന്ന സമയത്ത് ദാറ്റ് can be the biggest opportunity that we can tap into. And I think in MuLearn also, and the student community also, that is, there should be more space related discussions happening, and more opportunities for sure there will be there. അപ്പോൾ അതിനകത്ത് നമുക്ക് monthly once എങ്കിലും ഇതുമായിട്ട് ബന്ധപ്പെട്ടത് ഒരു ഓഫീസ് അവേഴ്സ് നമുക്ക് ചെയ്യാനായിട്ട് പറ്റുമോ? വി വിൽ കം അപ്പ് വിത്ത് സം ലേണിംഗ് പാത്ത്. ഹി ഹാസ് ഷോൺ ദ ലേണിംഗ് പാത്ത് ദാറ്റ് ഈസ് അപ്പോൾ സം ലീഡേഴ്സ് ആർക്കെങ്കിലും അതിനകത്ത് പിന്നെ കോർഡിനേറ്റ് ചെയ്യാനായിട്ട് ഇപ്പോൾ എക്സാം അല്ലേ, എക്സാം ഒക്കെ ഒന്ന് കഴിഞ്ഞതിന് ശേഷം, ഇന്നുകൊണ്ട് ലോകം അവസാനിക്കാൻ പോകുന്നില്ല, ക്യൂറേറ്റ് ചെയ്തിട്ട് കുറച്ച് ലേണിംഗ് പാത്സ് ഇടാം. എന്നിട്ട് അതിനകത്ത് ചെറിയ ചെറിയ ചലഞ്ചസും പ്രോബ്ലംസും ഇടാം. സോ ദാറ്റ് പീപ്പിൾ ആരാണോ റിയലി പാഷനറ്റ്, റിയലി താല്പര്യമുള്ള ആൾക്കാർ അവർക്ക് മുകളിലേക്ക് വരാനായിട്ടും അവർക്ക് ഇത്തരം നെറ്റ്വർക്കിലേക്ക് ആക്സസ് നമുക്ക് കൊടുക്കാനായിട്ട് പറ്റും. ആൻഡ് താങ്ക് യു സോ മച്ച്.
Can you tell a little bit more about that training program in digital university? I mean, what is the length? What is the duration?
We just had a discussion with them last day. They are interested. So what we propose to them is to have a lab there. And we can make a curated training program with them for the students. And some people can also work with our programs as well. So that is a proposition what we gave to them. And it is not only with DUK, like colleges in the city can also participate. That will act as a hub kind of thing, and other colleges will be spoke. Ashraf.
So now let's have a photo together. The Iron Man of Kerala. Iron Man of it. Yeah. രാജീവ് ചേട്ടന് നമ്മൾ ഇതിന്റെ ഈ കാര്യങ്ങളെല്ലാം നമുക്ക് സ്റ്റുഡൻസിന് അവൈലബിൾ ആവുന്ന രീതിയിലേക്ക് ക്യൂറേറ്റ് ചെയ്ത് കൊണ്ടുവരാനായിട്ടുള്ള ഉത്തരവാദിത്തം നമ്മൾ ഏൽപ്പിക്കുകയാണ്.
രാജീവ് ചേട്ടനാണ് ഞങ്ങളുടെ എന്റെ ഇൻസ്പിറേഷൻ. നമുക്ക് വർഷങ്ങളായിട്ട് അറിയാം.
നമ്മുടെ മ്യൂലേണിന്റെ ശ്രീനാരായണ ഗുരുവാണ്, ഗുരുദേവനാണ്.